In this video, we're going to review how to do some rounding, and we're also going to tie that in with significant figures. So please make sure that you watched the significant figures video or did that lesson before coming to this lesson here. Before we go into rounding, you do need to be familiar with terminology when it comes to numbers. So for example, if we're looking at this number over here, let's make this screen a little bit larger. If we're looking at this number over here, there's two parts to it separated by a point over here, and that point is called a decimal. Decimal point. The left side, so the 1328, that's the whole number part. So that's the whole number. The right side, so the 1095 there, that's the fractional number part. So number part. So for example, just a simpler number than this one here to look at. If we had 1.5, the decimal points here, the 1 is the whole number part, and the 0.5 is the fractional number part. It's a fraction of a whole. It's half of a whole. So that's how you could refer to parts of a number like that. Now these decimals or these numbers have different names based on their location. So the first number that comes up after a decimal point is the tenths position. The second number is the hundredths position with a th there, th. The third is a thousandths, and then 10,000ths, and you can keep going like that. But notice it's all ending in th when you're on the right side of the decimal, ths, th. Now, when you go to the left side, the first digit is the ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you have to open up space for another digit, and that would be the tens, and then the hundreds, and then the thousands, and you can keep going so on and so forth. So those are different positions that we sometimes refer to when we tell you to round to a certain position in the number. So you do need to be familiar with rounding rules, and there's a neat poem that you can use to teach you how to round. And so the poem can be found over here. Find your number, circle it, look next door. 4 or less, just ignore. More than 5, add one more. If exactly 5, be sure to even up the score. So let's take a look at what that means and how that works. If you're rounding and you have numbers that are 0 to 4 next to the number you're trying to round, you're just going to keep it the same. You're going to round down. So for example, suppose we want to round this to 2 digits, 2.33 to 2 digits. So this is our first digit. This is our second. That's 2 digits there. We have to look next door here to where we want to round to. That's a 3. That's less than 4, or that's 4 or less. So this is going to be rounded down to 2.3. Now, suppose we had rounding of 5. So we want to round to 2 digits again. But this time we have 5, because here we had 0 to 4. Now we have 5 next to our digit we want to round to. So what we do is we have different rules here. If the number before is even, we keep it the same. We round down, in other words. If it's odd, we make it even by rounding up. Because if we only went one direction, up every time, we'd be rounding up more than we'd be rounding down, for example. So what we do is we come up with a system to make sure it's a nice even round up, round down situation. Otherwise, we're rounding up too often. If it's a non-zero that follows the 5 as well, then you round up. So let me show you some examples. So we want to round each of these to 2 digits. So we have 2.45, for example. So 2.4, look next door. This is an even number, so it's going to round to 2.4. Okay, 2.55. So 2.5, 2 digits there. Look next door. That's a 5. Our 5 over here is an odd number, so we round this up to 2.6. Now over here, if it was 2.45, we'd leave it at 2.4. But notice we have 2.45 and then 3 there. So this is above that 0.05 value. So we're going to round this whole thing up, 2.5. So if I didn't have anything afterwards, you just leave it at 2.4. But since I have that digit there, 2.5. Rounding up. So if you're rounding from 6 to 9, you just round up. So for example, over here I have 4.88, and I want to round it to 2 digits. So this is my second digit here. I look next door, and that's higher than 5, so 6 or 9, 6 to 9. And so this would become 4.9. I'm basically just adding one more to that digit there, because I'm closer to the 4.9 than I am to the 4.8, for example, and that's to 2 digits. Another way I could have said this is round it to the tenths place here, and same idea here. These are all the tenths place that I'm rounding to. So that's our next door there. And over here, 2 digits as well, the tenths place, tenths. So now what happens if you're doing operations? So if you're adding, subtracting, multiplying, dividing. Well, if you're adding or subtracting, you need to follow the precision rule, which basically means that you need to follow the measurement with the least precise decimal places. In other words, the fewest decimal places. So suppose we're subtracting these numbers here. We're doing a subtraction. 6.98 minus 0.345. The one with the least precise decimal places is 6.98 because there's only 2 decimal places here. So our final number should have 2 decimal places. So let's put that in our calculator, 6.98 minus 0.345, and we get 6.635. And I'm going to round that to the fewest number of decimal places, which is 2 in our question. So 2 over here. And so what I need to do is I need to look next door here, and notice there's a 5. So I need to round this up to make it even. So that's going to be equal to approximately 6.64. So I left it to 2 decimal places rather than 3 decimal places, which is over here. So 2 decimal places rather than 3 decimal places. So you can try this one, pause the video and try it yourself. But we're adding this time, and it's the same rule as the subtracting rule. We want to look for the fewest number of decimal places. Here we have 3, here we have 2, so we know our final answer needs to have 2. So in our calculator, 7.255 plus 0.26 is 7.515. We want to keep 2 decimal places. So about over here. So we're going to look next door here, and it's going to round up to an even number, so 7.52. And that's 2 decimal places. Now, if you're multiplying or dividing, you follow what's called the certainty rule, where you follow the measurement with the least precise number of significant figures, not so much the least precise decimal places, but the least precise number of significant figures themselves. So I look for the fewest significant figures, and that's what I'm going to follow. So for example, between 7.82 and 4.656, this has 3 significant figures, and this has 1, 2, 3, 4. This has 4 significant figures. So I need to make sure I have 3 significant figures in my final answer when I'm rounding. So 7.82 times 4.656, and that gives me 36.40992. 40992, but I have to keep it to 3 significant figures. So basically up until here, if I look next door here, that's just a 0, so I can round down to 36.4. And that is 3 significant figures for the multiplying dividing rule. So what I want you to get right now is that when you do chemistry questions now, you don't have to ask your teacher, how many decimal places do I keep? Because you now know the adding, subtracting, and multiplying, dividing rules. You follow those rules when you're dealing with measurements in chemistry and other sciences like physics, for example, unless you're told otherwise by your teacher. So let's try this one here. 97 divided by 2.45. We have 2 sig figs here. 2.45 is 3 sig figs. So we want to have our final answer as 2 significant figures or digits. So let's do this in our calculator first. 97 divided by 2.45. And we get 39 point, we have a whole bunch of decimal of fractional parts there. 5, 9, 1, 8, 3, 6, 7, 3. And so if you kept your answer like this, you'd kind of be lying. Your most precise measurement is 97, and here you're reporting that you have such a precise instrument that you're measuring with. You're basically saying you can measure all the way to this precision over here, which is a lie. You're not really doing that, right? So that's why you need to follow those significant figure rules, because you can't be more precise than your least precise measurement. It doesn't make sense. So we need to have 2 significant figures. That basically means over here. So let's look next door. We have 0.5. So we're going to round this up. And when we're rounding this up, we're going to get to 40. That's one significant figure. So to make this count as 2, you need to make sure you put a dot here, 40 dot, or you could have done this as scientific notation, 4.0 times 10 to the power of 1, and that would have worked as well. Because you're rounding up here, not because you have a 5 there, and also the 5 is followed by a string of numbers. And so you'd be rounding up to 40 dot, for example. So that there was the major rules for rounding, and we incorporated significant figures in there as well. We'll do 2 problems together. Generally in chemistry, you're going to have problems where you have mixed adding and subtracting, multiplying and dividing, a whole bunch of them together. When we have those situations, you'll get more instruction on that, but basically you're gonna make sure your final answer has the smallest number of significant figures that's seen in the question itself. But if you just have a pure sort of adding or pure sort of multiplying, dividing, just follow the adding, subtracting, multiplying, dividing rule. For example, what is the total mass of 33.0 grams of KCl and 56.50 grams of H2O2? So you're asked for the total mass here. And that means we're going to add the 2 masses together, grams, plus 56.50 grams. And since we're adding, we're looking at the fewest number of decimal places. And so we can see that in this question, 1 is the fewest number of decimal places. So if we do 33 plus 56.5, we get 89.5. Don't put 50 because then you have 2 decimal places. We don't want 2 decimal places. We want 1 decimal place, as you see over here. And don't forget to put your unit back to 89.5 grams. And then, of course, we can do a problem where we have our division. So what is the density of an 87.545 gram metal sample with a volume of 2.0 cubic centimeters? And so our density formula is D is equal to M over V. We have a division happening here. So we have D is equal to M over V. So our density in this situation is going to be 87.45 grams over 2.0 cubic centimeters. And that's going to be, let's put that in our calculator, 87.45 divided by 2.0. We get 43.725 grams per cubic centimeter. Now we need to round, and usually, like I said, you want to round at the end of a problem. And there's only one step in this problem, so it's not too difficult. It is the end here. We need to choose the correct number of significant figures. So since it's a division, it's the fewest number of sig figs. We have 2 sig figs over here, and we have 4 sig figs up here. And so that's a nice easy win. The 2 sig figs will win this one. So that's going to be equal to approximately, we want 2 sig figs. So ending about over here. So we're going to look next door, and we can see that we're going to have to round to 44 grams per cubic centimeter. And so that there is just some sample problems, word problems, where you're taking a look at significant figures when rounding. And like I said, you no longer need to ask your teacher how to round because you know these significant figure rules now and how they work. On the next few pages, there's some practice problems you can attempt. There will be a video or answer sheet for you to take a look at to make sure you're on the right track.